Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC, we do everything DIY, and today we have a service call for an HVAC unit serving the switchgear room. Thank you to everyone tuning in to Jumperman Tech. This is quite the switchgear room. So right now, it's really hot in here. It says it's 88 degrees, system's currently on off. Anyways, over here we have the AC. Looks like it's another Johnson controls unit. Let's go ahead and open up the control panel. It's gonna be on this side. This is I can see it's already water source, and it must be just like the other units, a water source heat pump. All right, we got quite the control panel here. Definitely recognize this. Control board, relay, contactor, transformer, phase monitor, thermostat terminal strip. Here's our water actuator, thermal expansion valve, our liquid line dryer. I can see back there, it's a pressure control. It's gotta be our low pressure, the two blue wires, that's connected. Let's see, because this building is full of hacks. All right, we have our water strainer here. Definitely something we're gonna wanna look at. What happened here? Here's this side over here. You can see the compressor. This is our condenser coil. Our high pressure switch here is connected. Our low pressure up top there is connected to blue wires. This low pressure was so hard to get to. It's right against the ceiling. It's really a poor design. Anyways, I got my digital probes to read pressure. Also my digital temperature gauges. Over here, we're gonna read all that. Let's see if we can start anything and see anything. All right guys, so real quick, we have a standing pressure of 247, and this is refrigerant 410A. Standing pressure looks fine, unless it was, actually might be somewhat high from what we usually see. You know, nobody's coming up here on a 10-foot ladder and pulling this strainer anyways, or if that water valve is not opening. Let's turn the unit on and see what happens. Okay, Christian put the system on cooling. I hear the fan running. That's gonna be our evaporator fan. Let me see something. So right now this actuator is moving. You can see the black stem up top. It's moving very slowly to the left right now. So we should have some water flow. And because of that, it's affecting our pressures a little bit once that water is flowing. Feel it a bit. All right. That's why we have a change in pressure. We got water flowing, actuators open. Let's see what happens. Probably got like a 5-minute delay on here, and we'll see. It's been a few minutes, and definitely with the water flow, our pressures came down. So 218, 219 standing pressure. Let's give this thing a few minutes and see what happens. Just pulled out his filter a little bit. Look, this thing is completely packed. I wouldn't be surprised if it's tripping on low pressure. And it's a 1-inch filter, but you can see this is a 2-inch racket. I can stick my hand in here, it shouldn't be a thing. So filters are definitely packed, and once again, they don't do maintenance in this building. So let's see what's going on. Let's see what's going on.
2,000 years later.
Okay, so the system was not starting. So what we did is turn on the thermostat, then we killed power, turned the power back on after 5 minutes, turned the thermostat back in cooling, and the system started. Right now, everything seems pretty normal. Our suction pressure is 133, liquid pressure, right, 291. Got a pretty good temperature. Look, our superheat is at almost 9 degrees. Subcooling at 12. Seems normal, completely normal, so our pressures are good. So why did this thing not turn back on until power was cycled? So what that's telling me is that it locked out on some sort of safety control. That's the only thing that makes sense. So it locked that on some sort of safety control. What I've seen in 2 of them is that the condensate switch was jumped out. Where is the condensate switch? So here's our board and terminals. I'm gonna take a picture so you guys can see. But terminals 24 and 25, which is 2 brown wires, labeled as 60 and 61, is our CO. CO is a condensate overflow sensor. We gotta check to make sure that this drain is not plugged. It's like a similar story with a lot of these units. It's gonna be the 3rd one just like this. And I wouldn't be surprised if that's what it is. You might just need to do the maintenance on here and see what's going on. Gotta find that drain line. I see it. Oh, there, we gotta blow that thing out. We're in a garage right now. Let's check some temperatures, but honestly, right now, everything seems normal. It's actually a little bit of a chilly day out, so high side, just everything making sense. But at the same time, actually, this is water cooled, but temperature still plays effect because it's connected to the cooling towers. So if, you know, if it's cold outside, that water is gonna be colder than it would be in the summertime. It's been a little while, and honestly, these pressures and temperatures look good. Room already came down 6 degrees. Nothing, you know, it shouldn't shut off on low pressure, it shouldn't shut off on high pressure. Unless, you know, that actuator is acting up, it doesn't open the water, it would shut down on high pressure. Something locked this thing out. The only thing that makes sense, because the other units had that issue, like I said, that condensate switch, that CO. So what I want to do is let it run and then go check the pan, if anything, pour some water down there and see if there's water sitting in there and it's not draining properly. All right, Christian just turned the thermostat off. Look at this filter. This thing is completely packed with a bunch of bugs in it too, but this thing is done. Shameful, shameful. So it looks like, how many? There's 2 of these. All right, take that. I might need to get the other one from the other side unless there's something. Okay, what I want to do is, oh, you know, Christian, let me get the long extension for the drill. We got to change those filters, try to get them the right one. If anything, they need 20 by 20 by 2, not by 1. I don't think I can. Oh, maybe I can get in there. Let's see. The extension would definitely make it easier. Got to be careful because the fan is still running a little bit. Even though we turned off the thermostat. There we go. Okay, let me also get a flathead real quick. Thank you. Sure. Okay, there we go. All right, Christian. Yeah. See if they have those filters in stock. We need 2 of those. All right. 20 by 20 by 2. Oh, this is good. You can get to everything real well over here, and the condensate switch. This condensate pan is dirty, man. Yeah, I wouldn't be surprised. What the? This is what got it. Whoa! I think it was barely on there. Those electrical connections, man. This condensate switch is no good. That thing like pulled right off. Let me take a picture so you guys can see. Alright, I'm definitely gonna clear some of this because some of this stuff is just so thick you don't even want that going down the drain. Power is off on the unit. I'm thinking maybe when the two wires feel water, right? Maybe when it feels water, that's when it trips, when it senses water. Anyways, let me clear this out a little bit and then pour some water down the drain and see what happens. But this pan definitely needs to be cleaned. This is completely unacceptable, and that's probably why it tripped. This thing is so loose. Oh, look, it fell already. Unreal. Anyways, let's clean this up. Let's see what happens. I just filled up this pan with water. Look at that. This drain is clogged. This switch definitely went off. This thing is packed up. All right, so that's what happened. It was dry and it came back on because everything just evaporated. All right, let's change the filters. Let's clean this pan. Let's blow out the drain. While we're at it, let's clean the water strainer. But this water is clearly just sitting in here. All right, we do have a vent after the trap. You know what? Let me close this. Maybe with my elbow and hold this closed as well. Let's blow this out. See some water movement. Close this trap too. Look how that water's traveling now. There's definitely some stuff in here. What the heck was that? Some thick stuff was in that drain for sure. Should have blown this out both ways. Here's the other side of that drain. We are now draining. Let's blow it out through here too. Okay. And let's see what happens. I feel like we might need to even snake this thing, but I blew it out and it is starting to drain. And you can see it is coming back down again. It's coming down, but it's so slow. Look, this thing is still full of water to where it would trip the unit. I don't like how slow that's dripping. We got a trap. Like this could even be curved a little more. This is like straight. Oh my, you got a tiny pitch here. And it goes through here. Goes through there. Here. Here. Here, very slight pitch. And we got water coming out a little better now. I don't have my light, but it is coming down, but it's super slow. Here's the new filters. They're pleated and they're by 2, 20 by 20 by 2. There's an arrow on the filters. So you can see airflow. So it's always gonna be facing the coil. Let's see. Towards the coil. So right here, you see, and you're gonna see how this fits much better. Let me put the hangers kind of in a bad spot. Where they make this a little difficult, but this is really gonna protect the system now. Let's just get it in there. See, now it's full. Next. Yes, sir. Flow towards the evaporator coil every time. Let's just fit it in there, get that in there. So filter is taken care of, the coil looks okay. We need to clear this drain, that's the main thing right now. Blew this out multiple times, but this water is just sitting in here. I wonder if this trap is clogged with all that dirt. Oh man. This is definitely a problem, or this thing is not pitched right. Just cut this off. Honestly, this thing is just sitting in here. It's barely draining. Something's up with that line. We need a better way to like attack this. If anything, maybe cut it here, block this off here, and shoot it out, try to clear that trap, or we gotta cut this thing. Maybe cut it here after the hanger, so you have support here and have support here. We have it clear, and we try to clear this out as much as we can, because this thing is not draining. It's either the trap, we got a poor pitch on here, but this thing is barely draining. It drained better at some point. We had like a few drips and then it started draining, but this pan is staying full. I just poured down 2 liters of water. Looks a little better now, but this thing is clogged, man. I would love to cut this here and snake this trap, possibly cut it here and watch this thing drain properly. They brazed this, but then they soldered the cap. Very interesting. Why not? Why do both? Anyways, all I do is go around on 2 pieces, and I cut evenly in the middle, so you could always put this back right there. It looks like 3/4 copper right there. If anything, we cut it and we could watch it drain, and from here we'll know, is it issue here or is it down the line? Got a pipe cutter here. I'm gonna cut this. This thing is barely draining. We need to figure out a solution because we cannot have this switch gear room at 89 degrees, especially in the middle of the summer. Get ready, Chris, all right? Watch your face. Okay, right there. Now it's starting to go down. Definitely going down now. It is draining through here. Might have a clog through this line. Starting to go down. Still kind of slow, but it's going down. See? Try to keep this above here for now. All right. Now this pan is draining. You see how there's no water in here. It all came out. Something is up. Either I just cleared it up right now magically, or this line is clogged here. That's a long run. All right, stick it in there, cover this, see if this even works. I might need to get an extension for this hose. There's something in the trap. Okay, should have blowed this out too, this other line. You can. Christian, go to the edge over there, the edge of that pipe, see if there's air coming out. Let me know when you're there. It's coming out? Okay. All right, Chris, come here. Might be the pitch. Let's bring this down. Like a lot of air was coming out? Yeah. Okay. All right, let's pour this water in. This should come out fairly fast. Oh, Chris, let's get tank. Let's clean out this pan with whatever water is in there. But it's coming out a lot quick now. Look at that, it's draining good. We should have that much water pouring through this thing. Let's get some more water, Chris. Should have water like that. Yeah, if anything, I wonder if this thing is just not pitched right. Oh man. Just put a little bit of electrical tape just to put this together real quick. Christian's gonna pour water down here. He's gonna watch the level of the pan, and I'm gonna be on the other end to see what's going on. I think we just have a bad pitch on this drain, honestly. All right, he's gonna pour that down. And let me see what's going on here. See if the level also goes down in the pan, okay? It is coming down. Let's just see how good it's coming down. Just pour it right in there. It's in there all the way? Yeah. Is it draining? It is? Yeah. Nice. So it's making its way down the line. Let's see. Let me get any better flow here. Right there. Look at that. Okay, it is better. That is definitely the best flow that we've seen. Also blade down on the pipe a little bit. That's a lot better. Nice. All right. Let me go up there for a second. Come down. Yep. You poured it all the way? Yeah. All right, come down. You can get another, fill that up one more time.
Gotcha.
Let me check. And it's coming down on the pan?
Yes.
Okay. It wasn't coming down before. Oh yeah. It's coming down. And it's not like a ton of water. This thing is like clear. That's beautiful. All right. Let's get a fitting and press this back on. Mosquito. Anyways, we just put another liter of water down there. I can see it moving. Not too fast, but it's coming down now. Let's take this off. And I also saw on the other side, it was pouring out after like a minute. So it takes a little time for water to get down there. Let's get rid of this tape. What we're gonna do is we're gonna press this together. See that draining? Anyways, what we're gonna have to do is actually cut this pipe. So I have, this is 3/4 copper. So these are press fittings. These are not, I usually have like slip couplings, and then I could just use two, but in this case we're gonna have to cut another piece. Okay. Have to cut another piece. Okay. Let's see, maybe right here in the middle. So we have a decent amount of space right there. And we're gonna have to fit those two up together. So I'm just gonna cut this, put two couplings and a fitting in between. But you know what, before I do that, can I put one? I don't think so. Might be a little tight. But you know what? I could. Alright, let's be careful here. So this is what I'm gonna do then. Since I have the space to do it, I'm gonna sand down both sides of the pipe because I'm free to do so. Let's get a nice clear connection here. And then ream both sides of the pipe. And we're gonna press this one fitting. Just because we got the space. Just gotta be real careful when you're doing something like that. A little bit of space. We can ream the inside and outside of these pipes so it's nice and smooth. Alright, this is a reaming tool. Let's get it. Everything is nice and smooth. Let's get this in all the way. Let's push this a little. Get my glove out of there. Okay, kind of broken there. Make sure there's nothing in there. Oh, yeah. Get that out. Make sure that's fully in. Got my press tool set up. 3/4. Okay. One, two, and three. Done. Best investment ever. All right, just gonna dry this out, make sure we have no leaks, and we're gonna test for water once again. Put this piece of insulation back. I can tape that. Okay. You got water?
Yeah.
Let me get it. And we're gonna test it down a few times and flush this out. Make sure this pan goes down. And that's why this machine was tripping. Let's see what happens. Chris, look on the other side. Make sure the water's coming out over there, okay? All right, I can see it flowing slowly, so let's see what happens. There we go. Got a decent amount of flow, and that should empty out the pan. You can even see some debris that came out of there into the bucket. That's definitely no good. So basically just flushing out that pan with some water, make sure it drains. All right guys, this pan is dry. Everything is good. I'm gonna put this insulation back, put it right here. Just gonna tape it up the seams, but we're good to go. I sanded out the edges here, put this back. What I think is that when water touches that, it actually cuts off the unit. I think when there's like continuity between them, possibly it shuts it down. I need to double check that, but anyways, let's close this back up, pull that strainer, and let's monitor this unit with the test. Pressures, temperatures, and all that good stuff. Make sure it doesn't shut down. Okay, close that all up. Power, of course, is off. Let's close this valve, and let's close this valve here, a little ball valve. I want the supply and return to be closed. I can open up this little cap. Come on. There we go. Supply and return valve is closed. Cap is off. I think this is like a vent. Doesn't come off. Anyways, let's open up this little valve. Oof. Nothing splashed me, man. Anyways, nothing else coming out. Let me see. Is it clogged? A little something's coming out now. Oh, there we go. This thing is clogged. Alright. Got a little bit coming out now. Alright, another thing I can do. See if this opens. I think this is a vent. Should help it drain. I loosened it a little. And we got a little bit bigger droplets now. And of course my phone rings 24/7. I'm gonna try to loosen this. Hopefully it's not too tight. Might need to hold back. Just I don't got a good leverage. Why is this thing like that? Alright, hold up. Maybe here. If I move up, you don't want to break these pipes either. I can't even, it's real tight. Alright, hold up. Let's see. Hit my hand on the duct, but I loosened it. Bucket. This one was kind of clogged. I wonder if maybe this one is dirty. Pressure is actually good, but if you're gonna do the maintenance, you better do the full maintenance. Got a little bit of rocks in here. Needs a little bit of a cleaning, but it ain't too bad. It smells horrible. All right, everything's nice and clean. Just rinse that off. I use a little bit of a wire brush. Let me put this in here so I know I'm leveled right. There's already a gasket in there, so you don't need to put Teflon or anything like that. And this doesn't need to be that tight, guys. It doesn't need to be that tight. Hand tighten it and just snug it down a little bit so it's easy next time. That's it. Close this. And where's this little cap? Let's open up this supply. What happened with this? Oops. Jeez. Okay. Close this little cap. Could try to vent, but you'll probably be all right. Let's close this up. If anything, we could vent out a little bit through here. Let's turn this back on. Chris, let's put this back in cooling, all right?
Gotcha.
And drop, put the temperature to the lowest point that's there. I think it's set to 72. That'll be all right with that. Better than 90. All right, the fan started. And look at the actuator valve. You can see it spinning to the left. I can hear it opening and passing through. So now we should have water through here. Just make sure we got no leaks in here. This fully opens. Fan started. I think there might be a proving switch on there, and once there's water, then compressor starts after a few minutes. That's just a little bit of water when I was spraying out from there. And check temps. All right guys, everything's looking good. System's back on. Pressures and temperatures, everything looks normal for R14A water cooled. All right, that's that. And I got my thermometer in here. You guys can see we got 57 degrees. That is the direct return. We got the new filters, all that, and we should be good from here, guys. Let's just monitor this system. Let's make sure the temperature comes down, but there really shouldn't be anything to shut this down. And that just goes to show you how important it is to do maintenance. Final temperature reading, we got 53.8 degrees. And I closed everything up. Everything is dry. Everything is good to go. Pressures are good. Filters are clean. Coils clean. Water strainer is clean. Our condensate pan is clean. And nothing is tripping. And this room is starting to cool down a bit. It's quite the switchgear room. Oh, it feels so much better in here. And we're at 82 degrees at the moment. And it's really a huge improvement. So we're gonna wrap this one up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.